Hi girls. So this is the next clip, and this is following on from the gas law mind map that we just made. I'm now going to do a question which involves using the ideal gas law. Okay, and the question we're doing here is 2015 question 4 part J. And I want to do a big shout out to Sarah and Jessica who asked for this one. I'm doing requests now. It's great. Feel like a deal, Jay. And what we're going to do is part J, which is calculate the number of moles of nitrogen gas at a pressure of 1.85 by 10 to the 5 pascals and a temperature of 293 Kelvin in the 6.5 by 10 to the minus 5 meter cubed volume inside a new tennis ball. It says give your answer to one significant figure. So we're going to do that now. Right, so if you were not sure where to start, you know that it's something to do with gases. You know that there are only two gas laws available to you, the combined gas law, which we talked about, and the ideal gas law. As soon as you hear moles, you know that the combined gas law is not relevant because there is no representation for moles in that. It has to be the ideal gas law. So we have to use this equation, PV equals nRT. And just a reminder what this is. This is pressure, volume, amount of moles, a constant that's in your logbook, and temperature. Okay, that's what this does. It relates these concepts in a mathematical fashion. What's really important in this question is that everything is in the correct unit. Now, it just so happens for this question that everything is given anyway in the correct unit, but you should always check that pressure is in pascals, volume is in meters cubed, moles is just a number, so it doesn't need units, or is always 8.31 anyway, and temperature is in Kelvin. Okay, so you should always check those things. Remember, if you need to change Kelvin, you're going to use the number 273. If you need to change volume from meters cubed, it's centimeters cubed and multiply by 10 to the minus 6. Okay, so they're all things we've done before. You might need to go over them. But essentially what we're doing here is we're going to rearrange this equation for n because we're asked about the amount of moles. So we're going to write the equation like this: n equals PV over RT. And then what I'm going to do is I'm just going to double check my numbers that they're all in the correct units, that the number given to me is for pressure is in pascals, for volume is in meters cubed, for temperature is in Kelvin. And that's it. And it turns out that they are. So literally all I have to do now is put these numbers into the equation. So I'm putting in the pressure from the question, which is 1.85 by 10 to the 5 pascals. And I'm going to multiply that by the volume, which is 6.50 by 10 to the minus 5 meters cubed. And I'm going to divide that by the constant R, which is 8.31. And I'm going to multiply that by the temperature in Kelvin, which is 293. Again, I'm getting all this from 2015 question 4 part J. That's where I'm getting these numbers from. They're all given. And when you put all that into your equation, what you get is 0.0049. And we're going to round that up to the one significant figure as it asked, which is 0.005 moles. Like that. Is that okay? So I think the difficulty that one of the difficulties that the girls mentioned in their email was that you have to remember that the mark schemes that you get from study clicks are literally the document that's given to the examiners during the summer, right? So they give you every which way of doing a question. Now, obviously, and you should only do it one particular way. So we would have used this. It's possible for you to have used the combined gas law. It's a hell of a lot more cumbersome and it's unnecessary. So I think it's important to stress that if you're looking at a mark scheme and you're looking at different alternative answers and you can't recognize one that makes sense to you or that we did, please let me know what that question is and I'll go through it like I did here. And thanks again to Jessica and Sarah for bringing this one up. I hope that helps.